All right, we are recording. If you have objections, let me know. I am putting the links in the chat as always, and I'm sharing my screen. All right, hopefully I am sharing the right screen. Good, I'm screencasting. It is May 24th. All right, so we are going to be doing this all week. Independent Living, Section 2. All right, so go ahead and click the Google form for that, which should look like the little house with the heart in it. I probably should change that. I probably should change the image so you guys know how to disambiguate these things visually. I will do that later. I will change the color and image here so you guys can take one look and know which week you're working on. All right, three new learning targets. I can compute the perimeter and the area of a polygon. All right, I can compute the areas of irregular regions, and I can compute the volumes of rectangular solids. All right, so the idea here is that on section 2 today, on this week, we're just looking at floor plans. So we're looking at all the different kind of floor plans and designs and things, and we're going to be doing some geometry type stuff in order to get a sense for how big is an apartment with, like, say, 900 square feet. All right, let me put this maybe over here. I want to pin, and there we go. All right, now I can. All right, we got some vocabulary, and I'll talk about the vocabulary, I think, in the text, but we got congruent, which means the same. We got square footage, which is how the size of apartments and houses are measured in terms of internal space. We got the floor plan area, apothem, which I'll show you what that is. That is like a point from the center of a polygon to one of the sides of a regular polygon, I should say. Perimeter is when you add up all the sides of a polygon, and that's the perimeter. We're going to talk about, I'll talk more about the Monte Carlo method. That's a method for determining the volume or area of irregular shapes. And then volume is kind of like a three-dimensional, how much space is in a three-dimensional area. And then British thermal units, BTUs, which is how we measure like furnaces and air conditioners and that kind of thing. So go ahead and put your name where it says your name. And when it says, what are the learning targets? You just come over here and you copy and paste them. That way I know you looked at them. Go ahead and do that. Let me let my cat out, who's no longer happy being in this area anymore. She wants to go. All right, go, beat it. Unfortunately, we've created a monster. I've been letting the cat outside into like a little cat area, and now the cat wants to be let out at all times to go in her little cat area, and she bugs me about it. All right, let's do one. Yeah, let's do one of these warm-ups right here. We'll do two of them. We'll do two of them today, like Monday, Tuesday, Wednesday, Thursday, Friday. Wait, we'll do one. We'll do one. A square has a side of 16 feet. A square has a side of 16 feet. What is the perimeter of the square? Think about that for a second. If you were to draw a square, okay. Hopefully that was enough time for you to think about it. So, the idea here, whoop, 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 I got a square. And if one side is 16 feet, and if I know something about squares, that all the sides of the square are the same, right? If this is 16 feet, then that means that is 16 feet, which means that is 16 feet, which means that is 16 feet. So if I know one side of the square, I know the length of all sides of the square. And what is the perimeter? The perimeter is this outside the distance of when you add up all the sides of the square. So 16 plus 16 is 32. And then add 32 plus 32 is 64. So when you get right down into it, you could have had 16 times 4 would equal 64 feet. You always want to label with units whatever something you're measuring there. So that's kind of how you go about the perimeter of a square. All right, let me get rid of all that, and I'll go back to this, and there we go. Well, we're going to skip the rest of the warm-ups for now. We'll do the rest of these later in the week, since we're no need to do it all on Monday. How much space do I want? How much space do I need? All right. When you begin to look for a place to live, price and location are not the only factors you should consider. One important consideration is the number of rooms, the room sizes, and the layout of the living space. The information that is shown here, it is shown on a floor plan. A floor plan like this is a drawing of the layout and dimensions of rooms. The floor plan shown is for a one-bedroom apartment. Here is some of the information that a floor plan shows you. It shows you that the apartment has a kitchen. It has a dining area. It has a living room, and it has a bedroom and a bathroom. The bathroom, it shows you, has a sink and a toilet and a bathtub. And apparently it has one window. You can see that right there. See that little space there? That's a window. The bedroom is 15 feet by 12 feet. So it gives you an idea of the dimensions of the bedroom. And the bedroom has two windows, one on this side, one there. All right, so they've got two windows there. The living room is 20 feet by 12 feet, and it has one large window. Let's see. It looks like it has one large, this is the large window. It's a double window. And it has one doorway. There's the doorway. This door swings out, says the floor plan. The dining area is 8 feet by 7 feet and has 3 entrances and no windows. So the dining room has no windows, but it opens to the kitchen, it opens to the living room, and it opens to a hallway which goes into the bedroom. And the kitchen has cabinets, counter space, a sink, a stove, a refrigerator, one window, and one entrance. All right, there's the cabinets, there's the sink, there's the stove, there's the refrigerator. It has a window and it has one entrance. So examining a floor plan allows you to make intelligent decisions before you move in. It helps you determine what furniture will fit in each room, and everybody likes to have ample space that suits their living style, family size, and hobbies. Larger spaces are usually more expensive, so deciding what you want and what you need is a balancing act with what you can afford. All right, we're going to be doing some problems with this thing called base molding. And if you've never done any home improvement or whatever, this stuff right here, like, so all this wood that's at the bottom of the floor, you probably never even noticed this stuff before, but you'll probably notice that if you look in the room that you're in, it probably has base molding. Between the floor and the wall, there'll be this base molding. And then what that base molding does is it kind of covers up the ugly connection between the floor and the wall, right? Otherwise it would just be kind of weird. And this base molding kind of covers that up and gives the room a little style. I'm in like an enclosed porch area, and I got some really chintzy base molding, a thin strip of wood. This base molding is fairly nice. It depends, and it depends. It comes in various qualities, right? So this base molding is probably fairly, somewhat expensive. This is not as fancy as base molding gets, but like a thin strip of wood would be really cheap. And so you can get all sorts of different kinds. Calculating the quantity and costs of materials needed for a home projects. So we have Jerry here. Jerry is using the floor plan for his new home to help him purchase base molding for a place where the walls meet the floor. The plans are drawn using a scale of 1/4 inch represents 1 foot. He measures the walls on the floor plan with a ruler and finds they total 23.5 inches. So on the floor plan, he takes a ruler on the paper and he measures 23.5 inches of space that he needs to cover with his base molding. If molding costs $2.10 per foot, how much will Jerry spend on base molding? Here's how to solve a problem like this. Jerry needs to use a proportion to convert the scale measurements to actual measurements in feet. Remember or recall that a proportion is created when two ratios are set equal to each other. When setting up a proportion, keep like units in the numerators and like units in the denominators. So here is the setup. The scale is 1/4 inch represents 1 foot. So they started with 0.25, that's 1/4. That's 1/4 as a decimal. 1/4 inch is to 1 foot, what equals a number of inches on the floor plan divided by the actual number of feet in the room. And so once you set up this proportion with 1/4 inch equals a foot, or is in relationship or in proportion to a foot, what the number of inches on a floor plan equal the number of feet in the room, we can begin to set up a proportion like this. So in this situation, we got 0.25 over 1 equals, we got 23.5 inches of space on the floor plan we measured with our ruler. And then we'd like to know how many feet that is in the actual room. All right, so that's going to be, we're going to represent that with an x. That's a variable. We'd like to solve for x here. And to get that done, we're going to do that cross multiplication. Remember cross multiplication? We've got, oh, maybe this is I'm liking that I opened this up, right? 1 over 2 is the same thing as 2 over 4, and we can kind of prove this by cross multiplication. 2 times 2 is 4, right? 2 times 2. Hopefully we don't need to have that demonstrated, but I'm writing it anyway. And then we also cross multiply 1 times 4. 1 times 4 is 4. And then we know 4 is 4, right? We can say 4 is 4, the cross multiplication. This means these two things are equal to each other because 4 is 4. In this situation, we have the x, so we're cross multiplying. We're taking 0.25 times x, and then we are cross multiplying 23.5 times 1. Whoops, I didn't want to include that. I need to erase that. I don't want to include the x there. I want to cross multiply 1 foot with 23.5 inches. And now I need to redraw the other cross multiplication. There I go. I do want to include the x there. Okay, yeah. So x is being multiplied by 0.25. That's why it has 0.25 times x. And then it has 23.5 times 1 over here because they're cross multiplying over there. We know how to solve these. You guys are getting really good at that, right? We're going to divide by 0.25 on both sides of the equation, and we're going to find out that x is 94. X is 94. That means that Jerry needs 94 feet of base molding. 94 feet of base molding. And we know that the base molding costs $2.10 per foot. All right, so 94 times $2.10 equals $197.40. Jerry is going to end up spending $197.40 on base molding for this little project he's got going on. Woo, not so bad, right? So you kind of, what are the steps? The steps are take the scale, right? Put that into proportion with the scale over how many feet that equals. And then set that equal to the number of inches on the floor plan divided by the number of feet in the actual room. And then find out which one of these variables you need to solve for. Maybe sometimes it'll be if you're measuring the room, you'll be solving for how many inches are in the floor plan. If you know how many inches are in the floor plan, you'll be solving for, how many feet are in the room. And then you solve for x, right, with cross multiplication. And once you get x, you find out, do you take that number of feet or inches, and then you figure out how much that's going to cost you in terms of whatever materials you're buying. All right, let me see if I have any practice ones we'll do together. Yes, I have one practice one we'll do together. The length of a room is 17 feet. All right, the length of the room is 17 feet. When using a when using a 1/4 inch equals 1 foot scale, what is the length of the room on a floor plan? All right, so let me just give you a minute to think about this. Try to solve this one here. The length of a room is 17 feet. When using the 1/4 inch to 1 foot scale, what is the length of the room on the floor plan? I encourage you to try these when I give you time to think about them. That will help you, because even if you don't know it, if you don't know it, it actually becomes better if you try it. Because if you don't know it and you try it, by trying to struggle with it and be like, I don't know this. What's actually happening behind the scenes in your brain is your brain is struggling, and that's why you feel uncomfortable. It's like opening all these cabinets in your brain. Where have I stored this information? How do I do this? And then all those cabinets are open. And then when I show you how to do it, you're like, oh, now I get it. And then you know where to put. Now your brain already has those cabinets open. It then files all that stuff in the appropriate place, so that next time you've got a problem like this, you're like, I remember this. That's why it's so important when I say, oh yeah, let me give you a minute to think about this. Go ahead and try it. You give it a try. We learn by doing. We learn by doing. I would start with maybe a diagram. If you're stumped at this point, I would start with a diagram. I don't know that the room is rectangular. It just tells me the length of the room is 17 feet. So I don't know that the room is rectangular, but I'm just kind of drawing a diagram like, okay, 17 feet. 17 feet is the length of the room. The scale on the diagram is 1/4 inch equals 1 foot. All right, can you put that into like a proportion? 1/4 inch equals 1 foot. Maybe use the previous example as a reminder for how to do that. All right. That's how they did it. All right. They just put 0. This is being funny. There we go. Finally, it read it. 0.25 over, right? 1 foot. 1. Right. Okay. That's my proportion. Number of inches in the floor plan. I don't know how many number of inches are on the floor plan. That's going to be my X here. That's going to be my variable. I don't know how many numbers of inches, but I do know the feet. I do know in this case, the feet. So I can put 17 here. So I get a cross multiplication situation going on. I get X times 1 or 1X, right? I can cross multiply over here. Oopsie daisy. Let me pick green. Sure. Right, I'm cross multiplying here to get this. And then I am going to cross multiply over here to get this. And I'm going to go to my math machine to help me out with that one. Let's see, I could probably come up with it's going to be close to 4, like 4.25. All right, math machine, help me out here. I need to know what is 0.25 times 17. 4.25. Okay. 4.25. 4.25. And then we just got to solve. Well, actually, we don't have to solve for X, right? It's already done for us. 1X is the same as X. So X is 4.25. It's going to be 4.25 inches. 4.25 inches on the floor plan. 4.25 inches on the floor plan. That is how to get that done. All right, I am going to just erase this. And let me just talk about the rest of them, and then I will let you go to it. Let's see, we have Bruce using a floor plan for his new home to help him purchase a railing for a stairwell. The plans are drawn to a scale, drawn using a scale of 1/4 inch, represents 1 foot. Bruce measures the area that the railing needs to protect with a the railing needs to protect. Oh, good. Bruce measures the area the railing needs to protect with a ruler and measures 4.5 inches. Okay, so Bruce is, hold on. Let me get to the links up. I don't want that. What did I want? I'm trying to, Mr. K, can you get the links in there? Maybe I got it. Oh yeah, I think I figured out how to do it.
Just did it.
All right. He saved me. I couldn't figure out with all this stuff I got going on. I couldn't figure out how to do that right now. All right. So Bruce, he's got to put some railing up for a stairwell. He's got plans that are drawn to us using a scale of 1/4 inch, represents 1 foot. Bruce measures the area that the railing needs to protect with a ruler, and he measures 4.5 inches. If the railing costs $75 for every 3 feet, how much will Bruce be spending on the railing? All right, I'm not going to solve this one, but let me give you a minute to think about how do you do it. Take this second, just try to set this up for yourself. So you're working on the Bruce problem right now. Maybe you got some paper available to yourself. All right, let me talk about it at least. So there's some kind of railing. I'm just going to draw a picture. Maybe that helps. There's some kind of railing, and Bruce, this is on a floor plan, right? He's looking at a floor plan. He measures the area on the floor plan with a ruler, and he measures that on the floor plan. This represents 4.4 point. I'm having trouble doing points here. 4.5. There we go. All right, 4.5 inches. If the railing costs $75 for every 3 square, how much will you be spending? Okay, so I have a situation. What's the scale? The scale is 1/4 inch represents 1. So let me start with using a proportion here. I'm going to start with a proportion. 1/4 inch is the same thing as 0.25, right, over 1 foot. And that's going to be equal to the inches on the floor plan divided by the number of actual feet in the room. What do I have? I have the number of inches on the floor plan. So I want that to be up here with inches. All right, so that's going to be my x. So this is the problem I have to solve for. I am going to then cross multiply. All right, I need to take this, multiply that together, and then I need to take this and multiply this together. All right, so I'll do that over here maybe. It's going to be 0.25 times x is going to equal 4. Having trouble with those points. And my technology, I think it's dying. All right, times 1. Times 1 doesn't change anything there. So I'm just going to solve for x. I'm going to divide by 0.25 on both sides of this equation. And again, I'm not solving this one for you, so you have to break out your own calculator. X equals 4.5 over 0.25. That's the setup. That's the solution. You have to do that last step on your own. All right. And then I will, I'll stop. I'll wipe this out in a second. All right, there it goes. You'll solve this one, and then you'll do 2 more. You'll do 2 more problems with Janice and Tavion. Janice is using a floor plan for her new home to help her purchase molding for her ceiling. So this is not base molding, but this is going to be like the ceiling molding. Plans are drawn using a scale of 1/4 inch, represents 1 foot. Janice measures the area requiring molding on the floor plan and measures 56.25 inches. If the molding costs $3.25 per linear foot, how much will Janice need to spend to purchase the molding? This problem here is almost exactly like this example here. To use that, it's pretty straightforward. And then Tavion is using a floor plan for his new home to help him purchase tiling. He wants tiling for his kitchen. The plans are drawn using a scale of 1/4 inch, represents 1 foot. Tavion measures the area requiring tiling. So we're not doing length now, we're doing area. Tavion measures the area requiring tiling on the floor plan, and it measures 12 square inches. So you don't have to calculate the area, it's already 12 square inches. If tiling costs $15 per square foot, how much will Tavion need to pay to purchase the tiles? All right, those are the 2 that you're working on your own. I am going to stop my share here and stop the record. There we go. Stop.